cosmic event is happening right now, capturing the attention of astronomers worldwide. Betelgeuse, the mesmerizing red supergiant that adorns Orion's shoulder, is undergoing an astonishing transformation. Its luminosity, the radiant glow that defines its celestial presence, has surged by an extraordinary 50% beyond its usual brightness. At the start of this year, Betelgeuse was the 10th brightest star in our night sky, but this unexpected burst of brightness has elevated it to the 7th brightest star. Betelgeuse is a massive star in the later stages of its life, so large that if it were placed at the center of our solar system, it would extend all the way to Jupiter's orbit. Eventually, this star will collapse, resulting in a powerful supernova explosion, which could lead to the formation of either a neutron star or a black hole. The anticipation surrounding Betelgeuse's supernova is immense because, at about 650 light-years away, humanity is in a prime position to witness this cosmic event firsthand. When the supernova occurs, it will create a stunning light show. First, a surge of neutrinos will sweep across Earth, detectable by observatories worldwide. Then, as high-energy photons escape from the expanding cloud of stellar debris, Betelgeuse will rapidly brighten, reaching up to 100,000 times its usual luminosity over the course of a week. Depending on the explosion's power, this celestial beacon could rival the brilliance of a full moon and might even be visible during daylight hours, casting distinct shadows at night. This spectacular event will last for an extended period, offering astronomers an unparalleled opportunity for detailed observations and potentially groundbreaking discoveries. Although the supernova of Betelgeuse might stir speculation and unease due to historical associations with ominous signs, we can take comfort in knowing that we are safely distant and shielded from any harmful effects. To fully grasp the enigma of Betelgeuse, it's important to revisit the end of 2019 when peculiar phenomena began to manifest. During this period, the red supergiant started to dim significantly, a change noticeable even to the naked eye. Observations with the Very Large Telescope revealed that Betelgeuse appeared roughly symmetrical, but its outer layers showed signs of significant disturbance. The star's photosphere, the outer layer where light is emitted, also expanded, making the star appear swollen from our vantage point on Earth. This expansion continued at a steady rate of about 8 kilometers per second throughout most of the year until mid-November 2019, when the outward velocity began to decline. By mid-November 2019, the flow of material from Betelgeuse ceased, prompting astronomers to capture new optical images of the star. Their observations revealed two surprising irregularities: a darkened region in the star's southern hemisphere and a dip in surface temperature by approximately 80 Kelvin between January 27th and February 13th, 2020. About a year after the outflow stopped, Betelgeuse began to regain its brightness, eventually returning to its normal magnitude. This led to the question of what had truly happened to Betelgeuse. All the available evidence pointed to Betelgeuse experiencing an immense and unprecedented event known as a surface mass ejection, SMEE. This phenomenon is similar to coronal mass ejections, CMEs, observed on the Sun. Imagine a volcanic eruption on a star scale. Material from the star's interior surges upwards and outwards, causing shock waves within its atmosphere. Over time, this material forms molecules and dust, partially obstructing our view and causing the star to appear dimmer. In Betelgeuse's case, this resulted in the ejection of a mass 400 billion times greater than what is typically observed during similar events on other stars or CMEs, equivalent to multiple times the mass of the Moon propelled at astonishing speeds. This enormous mass ejection had never been witnessed before and allowed astronomers to observe surface details in real time using the Hubble telescope, offering a unique glimpse into the aging and evolution of a dying star. The SMEE had a profound impact on Betelgeuse, causing it to lose a significant amount of mass in a single event. It was as if Betelgeuse had forcefully expelled its upper layers and was now in the process of slowly recovering. However, following this dimming event, Betelgeuse's behavior changed. It used to pulsate or alter its brightness every 400 days, but now it is pulsating every 200 days. Betelgeuse is classified as a semi-regular variable star, meaning it experiences multiple cycles of fluctuating brightness due to variations in its size and temperature. This red supergiant is known for two main periods of light pulsation. The first lasting 400 days, believed to be caused by pulsations in the fundamental mode, and the second, a longer cycle of about 5.6 years, whose origin remains unknown. In their research, scientists used computer simulations to gain a deeper understanding of the events that transpired. They proposed that an unusually hot gas current, resembling a large and intense bubble, emerged from within the star. These hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion. As this hot bubble ascended and broke through the star's surface, it triggered the ejection of stellar material and disrupted the star's regular pulsation pattern. The star's surface continued to expand while its deeper regions contracted, causing Betelgeuse to transition from its usual 400-day pulsation to a new 200-day pulsation. Astronomers anticipate that the star's regular motions will gradually stabilize over the next 5 to 10 years, eventually restoring Betelgeuse to its normal 400-day pulsation. As for the possibility of Betelgeuse going supernova, astronomers speculate that it could happen anytime within the next 10,000 to 100,000 years based on the star's color, brightness, size, and estimated age. Scientists suggest that Betelgeuse is currently in the early stages of helium to carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a cataclysmic explosion. Since Betelgeuse is located 650 light-years away, any supernova event occurring now would only become visible to us after 650 years due to the limitations imposed by the speed of light. Therefore, it's unlikely we will witness the star's dramatic demise during our lifetime. One unique aspect of Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us an incredible opportunity to learn about how big stars like Betelgeuse behave as they age, including surprise mass ejection events. Recently, astronomers made a chilling discovery. For the first time ever, they observed a star consuming its own planet, located 12,000 light-years away in the constellation Ayla. Betelgeuse, with its intriguing name and prominent position in the night sky, has captivated human imagination for centuries. Its significance extends beyond scientific knowledge, as it has left its mark on pop culture and mythology around the world. Betelgeuse has a rich and diverse origin rooted in the Arabic language, initially interpreted as the armpit of the giant, though some scholars argue that it may represent a hand or shoulder instead. This anatomical association is reflected in various interpretations of Betelgeuse, often linked to anthropomorphic or animal figures across different cultures and mythologies. In ancient Japan, it represented a severed limb, while in Brazil it was perceived as a turtle's leg or a caiman's hind leg. The Sanskrit term for beetle translates to the moist one, tied to the Hindu astrology Ardra lunar house and associated with the tempestuous storm god Rudra. Throughout history, Betelgeuse has played a significant role in cultural practices and traditions. For instance, in Macedonian tradition, it symbolized domesticated animals and agricultural life in villages. In other regions, such as North Baffin Island and the Melville Peninsula, its rising marked the onset of spring and longer days. Betelgeuse's cultural prominence stems from its affiliation with the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it continues to captivate and inspire artists, writers, and filmmakers. There's much more to explore about Betelgeuse's recent transformation and its potential for a future supernova explosion. The ongoing transformation of Betelgeuse offers a fascinating glimpse into the life cycle of massive stars. Observations of its recent behavior have highlighted a number of intriguing phenomena that extend beyond its luminosity changes. For instance, detailed studies of Betelgeuse's atmosphere have revealed complex interactions between its outer layers and the solar wind. This star's unique characteristics have made it a subject of intense study, not only for its impending supernova but also for its current state and historical behavior. In recent years, astronomers have employed advanced techniques to analyze the composition of Betelgeuse's outer layers. Spectroscopic observations have shown that the star's atmosphere contains a rich mixture of elements, including helium, hydrogen, carbon, and oxygen. These elements provide critical insights into the star's nuclear fusion processes and the ways in which it enriches the interstellar medium with heavy elements. Such studies are crucial for understanding how massive stars like Betelgeuse contribute to the chemical evolution of galaxies. Another key aspect of Betelgeuse's study involves its magnetic field. While the magnetic fields of most stars are relatively weak, Betelgeuse exhibits unusual magnetic activity. Researchers have detected strong magnetic fields that appear to influence the star's stellar wind and surface activity. This magnetic influence could be related to the dramatic changes in luminosity and pulsation observed recently. Understanding these magnetic fields helps scientists explore how they might affect the star's evolution and eventual explosion. In addition to its magnetic field, the rotation of Betelgeuse is of particular interest. Unlike many other supergiants, Betelgeuse rotates relatively slowly. This slow rotation is thought to be a remnant of its earlier evolution and might contribute to its current stability and observed phenomena. The star's rotation, combined with its size and mass, plays a role in shaping the structure of its outer layers and the nature of its mass ejections. The evolution of Betelgeuse is also closely tied to the dynamics of its surrounding environment. Observations have shown that the star interacts with a complex system of nearby stars and interstellar material. The gravitational effects from neighboring stars can influence Betelgeuse's mass loss and might even contribute to its eventual supernova explosion. By studying these interactions, scientists can gain a better understanding of the broader context in which Betelgeuse operates. Astrobiology also intersects with the study of Betelgeuse in intriguing ways. The star's position in the night sky and its dramatic changes capture the imagination of both scientists and the public. The potential for a future supernova explosion raises questions about the impact such an event might have on any potential planetary systems in the vicinity. Although Betelgeuse itself does not have known planets, its eventual supernova could influence nearby systems, potentially affecting their habitability or the formation of new planetary systems. The light emitted by Betelgeuse provides critical data for testing theoretical models of stellar evolution. By comparing observed data with predictions from these models, scientists can refine their understanding of how massive stars like Betelgeuse progress through their life cycles. This process involves complex simulations that account for various factors, including the star's mass, composition, and the physical processes occurring within its core. Another area of interest is the impact of Betelgeuse's mass loss on its future evolution. As the star sheds material, it alters its internal structure and influences the dynamics of its core. This mass loss can affect the timing and nature of its eventual supernova explosion. Detailed models that incorporate mass loss rates and their effects on the star's internal processes are crucial for predicting when and how Betelgeuse might go supernova. Public engagement with Betelgeuse has also been a significant aspect of its study. The star's striking appearance and dramatic changes have made it a popular subject for science outreach and education. By communicating the science behind Betelgeuse to a broader audience, astronomers can foster a greater appreciation for the complexities of stellar physics and the dynamic nature of the universe. The study of Betelgeuse also intersects with the field of cosmic archaeology. The star's evolution and eventual explosion will contribute to our understanding of the life cycles of stars and the formation of heavy elements. These insights are crucial for piecing together the history of our galaxy and the broader universe. By studying the remnants of Betelgeuse's eventual supernova, scientists can learn more about the processes that shape the cosmos. Furthermore, the observational techniques used to study Betelgeuse are continually evolving. Advances in telescope technology and data analysis methods have enabled scientists to gather more detailed information about the star and its behavior. Instruments such as the James Webb Space Telescope and future space missions will likely provide even deeper insights into Betelgeuse and other similar stars, enhancing our understanding of their life cycles and cosmic significance. Betelgeuse's unique position in the constellation Orion has also made it a key reference point for other astronomical studies. Its brightness and proximity to Earth provide a valuable benchmark for calibrating observations of other distant stars and celestial objects. This role as a reference point helps ensure the accuracy of data collected across various astronomical surveys and research projects. The scientific community continues to explore new theories and models to explain Betelgeuse's behavior. Each discovery and observation adds to the broader understanding of massive stars and their evolution. By combining observational data with theoretical models, researchers can develop a more comprehensive picture of how stars like Betelgeuse evolve and what factors influence their transformations.